So there's really, if we're going to solve exponential equations, there's really two ways of doing it. Try writing them so that the bases are all the same. And then if the bases are the same, you can cross those off and you just end up with x equals y. Or you can take the logarithm of both sides. That's the one that we're going to be working with mostly this week. So the first type, using common bases. So for example, if I gave you a problem like, and this should be review because we've done these types of problems before. But if I gave you a type of problem like 2 to the x plus 3 is equal to 4 to the, let's say, 2x. We can rewrite 4. 4 is the same thing as 2 squared, and I want to get a common base here. So this side, I wouldn't change anything. It would be 2 to the x plus 3 is equal to, and now the 4 I could rewrite as 2 to the second. Well, I still have that 2x there, so I just put it in there. So now the bases are the same, so I can just write the exponents equal to each other. So if I wanted to solve this, I'd get x plus 3 is equal to 4x. Subtract an x off there, so 3 is equal to 3x. X would equal 1. Now if I put that back in there, so that would be 2 to the fourth is equal to 4 to the, if I put 1 in here, 4 to the second. Is that true? Well, 2 to the fourth is 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the fourth is 16, 4 to the second is 16. So yes, that is true. So that's the first type of problem that we would do. And this is, if they have the same bases, these are the notes. We've already had these notes. Now, if the bases, if you cannot do that, then we want to take a common logarithm or a natural log of each side, use the properties of logarithms, specifically property number 5, divide each side by the logarithm, use a calculator to find the decimal approximation, finish solving the problem by isolating the variable. Okay, so this problem here. 4 to the x minus 1 is equal to 5. There's no way I'm going to be able to get a common base there. Okay, so what I'm going to do is I'm going to take the log of both sides, and I use the log base 10 because that's what my calculator has, base 10. So log base 10 of 4 x minus 1 is equal to log base 10 of 5. Now, I want to get rid of this exponent, so I'm going to bring it to the front, so that gives me x minus 1. I'm going to put it inside parentheses. I don't know why I wrote x plus 1. So let's go x minus 1 times the log base 10 of 4 is equal to the log base 10 of 5. Now I'm going to divide both sides. I want to get the x by itself, so I'm going to divide both sides by log base 10 of 4. Now this is where a calculator comes in real handy. X minus 1 is equal to log base 10 of 5 divided by log base 10 of 4. So I'm going to plug that into my calculator, log base 10 of 5, oops, I can't see here, divided by log of base 10 of 4, so log base 10 of 4, and I get an answer of 1.1609, and it goes on and on and on. So 1.160964. If I solve for x, x equals, I add just 1 to both sides, 2.16096. To check myself, I'm just going to plug this back in here. I'm going to put 2.1609, so that would give me, so that's minus 1, which would give me 1.160964 is equal to 5. Now, is that true? So I'm just going to use my calculator, 4 raised to the 1.1609, and then I'm just going to stop there, and I end up with 4.999555. Now, if I would have taken this out farther, it would get closer and closer, but it is really close anyways. So this is my answer. X is equal to 2.1609. All right, let's try the second one. So get rid of that. So the second one, same thing. I'm just going to take the log of both sides. So I'm just going to go log base 10, and I'm not going to write that in. Negative x is equal to log base 10 of 21. I'm going to bring the negative x in front. So that's log base 10 of 7 is equal to log base 10 of 21. I'm going to divide both sides by log. Oops, log of 7. So I end up with negative x is equal to, and again, calculator time, log of 21. So log of 21 divided by log of 7. And I end up with 1.564. And it goes on, I mean, for a long time. So it just keeps going. So my answer, I'm just going to make that a negative then. So x equals negative 1.564. And you can plug it in there and see if it works. I think you'll see it does. The next problem, I would just go log 2 to the 3x is equal to log of 15. I'd bring the 3x in front. And then I would divide both sides by log of 2. So 3x is equal to, again, trusty calculator now, divided by log of 2. And I end up with 3.90689. It just keeps going. So I divide through by 3 here. So x equals, let's see here, divide by 3. I end up with 1.3022968665. I'm just going to write down 1.302. And you can plug this in, see if it works. And you should see that it does. And I would always suggest checking your answers. All right. Solve the exponential equation. Okay, multiple choice here. Same thing. Just going to take the log of both sides. So log base 10 of 3 to the x plus 6 is equal to log base 10 of 8. I'm going to bring the x minus 6, or x plus 6 in front. And that's log base 10 of 3 is equal to log base 10 of 8. I'm going to divide both sides by log of 3. So x plus 6 is equal to, again, I don't know what that is, so I'll get my trusty calculator out, log of 8 divided by log of 3. And I end up with 1.92789. I'm going to subtract 6 from both sides. So I end up with x equals negative 4.1072. So I guess if you rounded it, this one would be the closest. Right there. Now to solve logarithmic equations. Okay, so we just solved exponential. Now we're going to solve logarithmic. A logarithmic equation is an equation with a logarithmic expression that contains a variable. You can solve logarithmic equations by using the properties of logarithms. Method 1. Okay, so I think there's really 3 methods here. Method 1, isolate the logarithm. Use inverse operations to move any part of the equation that is not part of the logarithm to the opposite side. Now this only works if there's just one logarithm in your problem. Now if you have logs on both sides or more than one log on one side, then this doesn't work, okay? But you're going to isolate the logarithm, and then what you're going to do is you're going to rewrite it as an exponent, and hopefully you should be able to solve it from there. Okay, in this example here, you got log base 3 of x plus 5 plus 6 is equal to 10. I would move the 6 over here, so you end up with log base 3 of x plus 5 is equal to 4. Well, now I've got the logarithm isolated, so my next step would be to rewrite it as an exponent. So that would be 3 to the 4th is equal to x plus 5. Well, 3 to the 4th is a number. So if I just plug into my calculator, 3 raised to the 4th power, I end up with 81. So now I have 81 is equal to x plus 5. Subtract 5 from both sides, and I end up with x equals 76. So that's one method. Now that method usually works when there's just one logarithm in the equation. If there's more than one, you're probably going to have to do something else. Okay, so here is another problem. This problem, I have just one logarithm, so my first thought is I'm going to rewrite it as an exponent. So I've got 6 to the negative 1 is equal to 2x minus 1. 6 to the negative 1 is 1 over 6, isn't it? Because the negative exponent just flips it. Is equal to 2x minus 1. I'm going to add 1 to both sides. So now I have 1 and 1/6 is equal to 2x. And then I'm just going to divide that by 2. I probably change it to a decimal, so 1 by 6. So I end up with 1.1666, and then I divide that by 2. So I end up with 0.58. So x equals 0.58. Now, this goes on. I mean, and to check yourself, you can just plug that in here, and you can see that it's going to work. So that's one method. If you have just one logarithm in the problem, it's probably the best method to use. Just rewrite it as an exponent. Now, if you have more than one logarithm in the problem, what you want to do is you want to use the rule, the product rule, or the division rule for logarithms, because you want to combine them. You want to make them one logarithm. Okay. So for example, if I had log base b of m times n, that equals this. This is the product rule. So here's an example. I have log base 4 of x plus 6 equals 2 minus log base 4 of x. Well, first thing I'd do is I'd bring that log base 4 over here, because then once I have it over on this side, I can rewrite it as a single logarithm. Okay, so now I rewrote the problem. I've got it on one side, so now I'm going to rewrite this as a single logarithm. So that would be log base 4, and since it's a plus sign, I'd multiply, so that would be x times x plus 6 is equal to 2. Now I'm back to method 1. I've got one logarithm. I'm going to rewrite it as an exponent. So 4 to the second power is equal to x plus 6. Oh, I'm looking like a quadratic now. So 4 squared is equal to 16, and that gives me x squared plus 6x. I'm going to bring the 16 over here, because anytime I have a quadratic, I want to get it set equal to 0. And then I'm going to factor. X squared plus 6x minus 16. That factors down to x. Does it factor? I think it does. X plus 8, x minus 2. So my answer is x equals -8 or x equals 2. Now you might want to check your answers by plugging them back in, see if it works, because if I put this negative back in here, that's going to give me a log base 4 of -2. Okay, so it might not work out. So you might want to check your answers. So here's their work here. So they did the same thing, 4 squared, and then they came up with x equals 2 or -8. Method 3. Now method 3 is just like method 2. It's just that it has a minus sign in between. So remember, if you have a minus sign in between a logarithm, then you rewrite it as a division problem. So if I had a problem like this, log base 4 of 100 minus a log base 4 of x plus 1, I would rewrite this problem as a single log. This would give me log base 4 of 100 over x plus 1 is equal to 1. Now I have a single logarithm. I'm going to rewrite it as an exponent. So I have 4 to the first power is equal to 100 over x plus 1. 4 to the first power is 4. I'm going to put it over 1 because I know how I'm going to solve this thing. I'm going to cross multiply. So I'm going to cross multiply. I end up with 4. X plus 1 is equal to 100. 4x plus 4 is equal to 100. 4x equals 96. X equals, that goes in there twice, so 24. Is that right? I think so. And then you can check yourself. This problem here, there's a plus sign, so I'm going to rewrite it as a single log. So this would be log base 12 of x plus 1 equals 1. Now, since I have a single log, I'm going to rewrite it as an exponent. So that gives me 12 to the first power is equal to x plus 1. And you'll see it's very similar to this problem. It's going to be a quadratic. It's going to end up being 12 is equal to x squared plus 1x. Subtract off the 12 and set it equal to 0 and factor. I'm sorry, it was similar to the last one that we did, a previous page. So that gives me x plus 4, x minus 3. So x equals -4, x equals 3. Logarithms are pretty awesome, I think. You really have to start thinking about how you're going to solve these types of problems. Now, a problem like this, first thing I would do is I'd bring that 4 to the front. Okay. Anytime I see an exponent, I always think about bringing it to the front. So I end up with 4 log base 5 of x equals 8. Now, I would divide both sides by 4. Why? Because now I end up with log base 5 of x is equal to 2. Now I'm going to rewrite it as an exponent. 5 to the second power is equal to x. 25 is equal to x. Done. So there are all different types of problems that you'll be thrown or will be thrown at you tonight or this week. So make sure you just follow the rules and the methods that I showed you. Please make sure that you come to the main lesson on Monday and we'll go through all the practice problems. Hope you guys have a great week. Bye.